Hi folks, and welcome to video number 98. This video is on sketching quadratics from a given equation. Keywords here are sketching, roots, intersection and vertex. When you're sketching something, you're just drawing it, and it doesn't have to be plotted exactly. It's not a beautiful thing. Well, it's a beautiful thing, but it's not a something that has to be perfect. Roots are the where the graph goes through the x-axis. They are the solutions that we get when we solve an equation. Intersection is where two lines meet, or a curve and a line meet, and the vertex is the minimum or the maximum point of that given curve. So when you're asked to sketch a quadratic, you're required to show some points of intersection, and they'll be specific in the question which ones they want. You can solve to find the roots of the equation, so you can solve that whatever the equation is to get the roots, and that's where the graph goes through the x-axis. So you make your quadratic equal to 0 to do that. Complete the square to find the vertex. That's one way of doing it. And sketching the graph, it's got to be made clear where the points of intersection are, specifically the ones you've been asked for in the question. So I'll do question 1 for you. Nice simple quadratic actually, this one. So let's make this equal to 0. Let's write down that x squared minus 7x plus 10 equals nothing, because that's the equation of, that's what we have to make the equation equal to in order to solve it. And this is just factorizing a quadratic. And if you don't know what I'm doing here, go back and watch the Factorizing Quadratics video. Finding the factors of 10 that add to make minus 7, minus 2 and minus 5. That equals 0, so then x would equal 2 and 5. I found the roots of this particular equation, so I know the graph needs to cut through the 2 and the 5 on the x-axis. I can also tell because of the original form of the equation that the graph is going to go through 10 on the y-axis. That's our y-intercept value. It always is the number on its own is where the graph is going to go through the y-axis, just like on linear graphs. Okay, so if we're going to attempt to do a little sketch, let's have mostly positive quadrant. We've got a little bit of the negatives there going on as well. So there's our origin. Okay, and then we'll have point 10 somewhere about there. Mark that on the diagram. Let's have 2 there, 5 there. Alright, and what we do is we draw a graph that goes through those points. Alright, and we're showing all the points of intersection between the curve and the y-axis, and the curve and the x-axis. Okay, showing the roots of the equation, showing where it goes through the y-axis. So we draw a quadratic shape. It looks like that. Okay, and you draw it as neatly as you possibly can, but it doesn't have to be to scale or completely perfect. That is a good enough sketch. All right. You might want to mark those as coordinate values. You might want to write it as 0, 10. They might want that in the question, and that is 2, 0, and that is 5, 0. That might be something that they ask for, specifically the coordinate values. Okay, so in question number 2, we've got a different equation. Again, we can make it equal to 0 and solve it. That's what I'll start off by doing. This time we've got to show all the points of intersection between the curve and the axes, as well as the minimum point of the curve. So we need where it goes through the y-axis, we need where it goes through the x-axis, and we need what the minimum point is, and we can complete the square to get that. So first of all, I'm going to find the roots just by factorizing and then solving. So that's going to be x. Factors of 15 add to make minus 2. Well, 3 and 5 work, so positive 3 and a minus 5 in the brackets, which means that x is minus 3 and or 5. There's our two roots. Okay, we know that it's going to go through the y-axis at minus 15, because that's the number on the end, it's the constant, and we just need to complete the square to get the minimum point of the curve. So I'm going to draw this over here. Alright, and then I'll complete the square here and find that bit as well. So let's mark on there minus 15 to start with. That could be minus 15. Let's have minus 3 there and 5 there. Okay, so we're going to go through like that. There's our quadratic. So we just need to get that minimum point. And to get the minimum point, complete the square, so x minus 1. Again, if you're not sure what I'm doing, go and watch that completing the square video in more detail in the algebra section. Square this number, take it away from the outside, so it's going to give us minus 16. So we can see that the minimum point equals, this coordinate has to make this bracket equal 0, or this value that I put in for x here makes this bracket equal 0 for the minimum point, and that will be positive 1, and then this value here is the minimum point value on the y-axis, so 1 minus 16, which is just down here. Okay, so what I'll do is I'll put minus 16 here, and then I'll just list those. I've got the minimum point, I've got the roots equal minus 3 and 5, and I've got the y-intercept. Doesn't hurt to do this, does it? Is minus 15. Alright, we've just labelled what each of those key things was. We've got that bit, that bit, and that bit. There's all our points of intersection. Okay, right, move myself over to have a look at the last question. This is a slightly more complicated one because we've got the negative quadratic here, which means it's an upside down parabola. Alright, instead of a U shape, we've got an N shape. We can still solve it though, and we can still complete the square for it. We just have to take the negative out at the beginning. So show all the points of intersection between the curve and the axis as well as the maximum point of the curve. So instead of it being a minimum point down here, it won't be that anymore. It will be a maximum point of the curve, and I will show you what you need to do. So let's take the equation, make it equal to 0. Alright, and then let's do what we can do with this. So let's take a negative out, and if we take the negative out, that just becomes an x squared, a positive x squared there, positive 2x, and a minus 8. Just the symbol changes in the equation there. That equals 0. Now we can factorize this. So that's going to be x and x, and then the factors of 8 will be 2 and 4, and it will be a positive 4 and a minus 2. And then to solve that, we're going to have in this bracket x equals minus 4 and positive 2. Okay, there we go. We have solved that. We've got the roots of the equation. Let's complete the square for it and then think about where the graph's going through these axes. So if we've got this negative that's come out in front of it, we're completing the square. X, I'm looking at this one here, x squared plus 2x minus 8. So I'm going to look at that because I've already got my negative outside this big bracket. I'm going to then put plus 1, square that, then minus 1 from that minus 8, which will give me minus 9. Alright, and then I can close it like that. And I'll put this big bracket around this because I've got this little bracket in here for my completed square. If you're not sure again what I'm doing with the completed square, please go and watch that video. And then I can see what values the minimum point is going to be. So the minimum point is equal to minus 1, and if I multiply that back through, that's going to be a positive 9. So I'll just put that like this. This is what this is an identity to. Negative x plus 1 all squared plus 9. Okay, so that number in there has to be negative 1 still, and this number here is going to be positive 9. Alright, so there's my minimum point. There's my roots. And the y-intercept value is positive 8. So there are all the things that we need in order to be able to draw this graph. Remember, it's upside down because it's a negative x squared. So we'll have more of the positive here. Really wobbly lines. Sorry, it's really difficult to draw straight lines on here. So minus 4, let's say it's about there. Positive 2 is about there. Could have done minus 4 over here, couldn't I? Let's do it over there. Let's start that again. There's minus 4. There's 2. Let's say there's 8. And minus 1, 9. That'll be our maximum point. Let me join that to there. And we go like that. If it wants to not disappear, there we go. And that is what that quadratic curve looks like. We've sketched that one as well. I hope all of that makes sense to you. Please drop me some comments if you want any more information on it. Haven't understood anything. Yeah, just give us a message, and I'll get back to you on it. Thanks so much for watching. Hope you watch some more. Like, subscribe, all that stuff. Take care of yourselves.